On March 8, 2025, commercial shipping traffic through the Baltic Sea was operating at near-capacity levels. Spring trade routes were opening after winter ice restrictions had eased. Container ships, oil tankers, and cargo vessels moved through narrow maritime corridors connecting Scandinavia, the Baltic states, and Northern Europe. The shipping lanes were some of the most congested in the world, with vessels passing within hundreds of meters of each other in carefully choreographed patterns managed by maritime traffic control. At the same time, NATO air forces were conducting routine reconnaissance flights over international waters. The missions were standard operational procedure, monitoring regional activity, maintaining readiness, collecting intelligence. The flight paths had been coordinated with civilian authorities weeks in advance. Shipping companies had been notified. Air traffic controllers knew the schedule. Every precaution had been taken to ensure commercial and military traffic could coexist safely in the same airspace. Everything was proceeding normally. Ships were following their programmed routes. Aircraft were maintaining their designated flight corridors. Navigation systems on both vessels and aircraft showed accurate positioning. AIS transponders, the automatic identification systems that broadcast each ship's location to prevent collisions, were transmitting normally. Radar systems showed no anomalies. Weather was clear. Visibility was excellent, but the positions being reported weren't real. At 14:23 UTC, the bridge crew of a container ship transiting the Gulf of Finland noticed something unusual. Their GPS indicated they were precisely on course, following the designated shipping lane at 16 knots. But the visual horizon didn't match what they expected. They should have been seeing the Estonian coastline to the south at this position. Instead, they were looking at open water in every direction. The discrepancy was subtle, maybe a kilometer, perhaps less. The kind of difference that could be attributed to chart imprecision or a momentary GPS glitch. The captain ordered a position check using backup navigation. The ship's inertial navigation system, which calculated position based on speed and direction rather than GPS signals, showed they were approximately 3.2 kilometers north of where GPS indicated. That was wrong. GPS accuracy was typically measured in meters, not kilometers. Inertial systems were less precise and tended to drift over time. GPS should have been the authoritative source, but inertial navigation was showing a more logical position. At that location, the Estonian coast would be visible exactly where they were seeing it. The captain made a decision. He ordered the helmsman to steer based on visual navigation and inertial systems, ignoring GPS temporarily. It was the correct call, but he had no way of knowing how correct it was. 14 kilometers to the northwest, a Greek-flagged oil tanker was experiencing the same discrepancy. Their GPS showed them safely in their designated lane. Their actual position, calculated by experienced bridge officers using radar and visual landmarks, was 2.8 kilometers east of where GPS indicated. They were drifting toward a collision course with northbound traffic, and their navigation system was telling them everything was fine. The Maritime Traffic Control Center in Tallinn was tracking 47 vessels in their coordination zone. Every ship's AIS transponder was broadcasting position data derived from GPS. On the traffic control screens, the ships appeared to be following their assigned routes with normal spacing and safe separation. But several ships had begun reporting position uncertainties, visual observations that didn't match GPS readings. Discrepancies that were small individually, but, when aggregated across dozens of vessels in congested waters, represented a catastrophic navigation breakdown that hadn't yet been recognized. At 14:31 UTC, a Swedish patrol aircraft conducting routine maritime surveillance detected the pattern. Their onboard systems compared AIS broadcasts from ships below with actual radar contacts. The aircraft's own GPS showed it was on course over international waters, maintaining safe altitude above shipping lanes. But their radar showed vessel positions that didn't match the AIS data. The discrepancy wasn't random. Every vessel was offset by approximately the same distance in the same direction, roughly 3 kilometers to the northwest. The flight crew ran diagnostics. Their GPS appeared normal. Signal strength was good. Satellite lock was solid. But when they compared GPS position to their inertial navigation system, they found the same offset that ships below were reporting. Their GPS was telling them they were 3 kilometers northwest of their actual position. That meant every vessel and aircraft in the region was navigating based on false positioning data. Ships thought they were safely separated when they were actually converging. Aircraft believed they were over empty ocean when they were drifting toward active shipping lanes. The GPS signals everyone relied on had been compromised. The Swedish aircraft immediately broadcast a navigation warning on emergency frequencies. They reported suspected GPS interference and advised all vessels to rely on backup navigation. The message reached maritime traffic control at 1434 UTC. Controllers began correlating the scattered position reports they had been receiving. Individual discrepancies suddenly formed a clear pattern. 47 vessels in their coordination zone were all navigating based on false GPS data. Their actual positions were kilometers away from where their systems indicated. Controllers began urgent broadcasts, ordering vessels to reduce speed and verify positions using non-GPS methods. But correcting the navigation of 47 ships in crowded waters wasn't instantaneous. Ships traveling at 16 knots covered over 400 meters per minute. They had momentum. Changing course took time. And until each captain independently verified their true position, they were navigating blind, trusting instruments that were feeding them carefully crafted lies. At 1439 UTC, the situation escalated beyond maritime traffic. A British RAF transport aircraft on final approach to an airbase in Latvia reported GPS anomalies. Their navigation system showed them aligned with the runway. Their radar altimeter showed correct altitude, but the runway wasn't where it should be. Visual contact showed they were offset by approximately 2 kilometers. If they had continued the approach based solely on GPS guidance, they would have attempted to land in an empty field. The pilot executed a go-around, aborting the landing and climbing back to altitude. The incident was immediately reported to military air traffic control. Within minutes, NATO command confirmed what civilian authorities were already discovering. GPS signals across the entire Baltic region were being systematically manipulated. The interference wasn't jamming. Jamming would have simply blocked GPS signals, forcing systems to report loss of satellite lock. This was spoofing, broadcasting false GPS signals that were stronger than authentic satellite signals. Receivers locked onto the false signals because they appeared legitimate in every technical aspect. The fake signals had correct timing, proper encoding, and valid satellite identifiers. They were just broadcasting wrong positions. Someone had deployed sophisticated GPS spoofing equipment with coverage spanning hundreds of kilometers of sea and airspace. The fake signals were precisely calibrated to create a consistent false reality. All receivers in the affected area were being told they were approximately 3 kilometers northwest of their actual positions. Ships were being herded together. Aircraft were being pushed toward unintended locations. And until the Swedish patrol aircraft caught the discrepancy, no one had realized it was happening. By 1445 UTC, emergency protocols were in full effect. NATO air operations in the region were suspended. Civilian aircraft were advised to avoid the area or rely entirely on ground-based navigation aids. Maritime traffic control ordered all vessels to stop or proceed at minimum speed until positions could be verified independently. Search and rescue assets were placed on alert for potential collisions that might already be in progress. The NSA's Signals Intelligence Network had detected the spoofing operation 7 minutes before the Swedish aircraft reported it. Automated monitoring systems designed to track GPS signal integrity had flagged anomalous transmissions in the Baltic region at 1424 UTC. The signals had the technical signature of GPS satellites but were originating from ground-based sources. The coverage pattern indicated multiple transmitters working in coordination, creating a spoofing dome that covered approximately 180,000 square kilometers of sea and airspace. The NSA team immediately began geolocation analysis. The spoofing signals were coming from locations along the Kaliningrad coast. The transmitters were powerful, estimated at several hundred watts each, enough to overpower authentic GPS signals across vast distances. The operation wasn't improvised. It required advanced equipment, detailed planning, and precise coordination. This was a deliberate test of infrastructure disruption capabilities. At 1452 UTC, NATO electronic warfare units began countermeasures. Specialized aircraft equipped with GPS signal analyzers deployed to the region. Their mission was to map the exact boundaries of the spoofing zone and identify the specific transmitter locations. Ground-based direction-finding stations began triangulating the false signals. Within 30 minutes, they had precise coordinates for 4 primary transmitter sites. The spoofing wasn't continuous. It pulsed, activating for periods of 8 to 12 minutes, then going silent for 3 to 5 minutes before resuming. The pattern made it harder to detect and gave the operators time to relocate equipment between transmissions. But it also created windows where authentic GPS signals could be received normally. Ships and aircraft that had lost reliable positioning began timing their navigation updates to these windows, treating GPS as unreliable rather than authoritative. Commercial shipping faced immediate crisis decisions. Ships in the affected zone had to choose between continuing with degraded navigation or anchoring in place until the situation was resolved. Anchoring wasn't simple in congested waters where exact positions were uncertain. Continuing meant navigating using decades-old techniques, dead reckoning, visual landmarks, far-ranging methods that required experience and constant attention. Many modern bridge officers had never trained for scenarios where GPS was unavailable. At 1518 UTC, 2 commercial vessels came dangerously close to collision. A Polish container ship and a Finnish bulk carrier were approaching each other in opposite directions through a narrow channel between islands. Both had been navigating based on GPS before the spoofing was confirmed. Both had attempted to correct their positions using radar and visual navigation. But the channel was only 200 meters wide at this point, and their position uncertainty was approximately 800 meters. Neither captain was completely confident of their exact location. The vessels passed each other with less than 200 meters separation, a distance that would normally be considered safe but became critically narrow when position uncertainty was factored in. If either ship had been 200 meters farther off course than their corrected navigation indicated, they would have collided. The Finnish vessel had 38,000 tons of grain in its hold. The Polish ship carried 4,200 containers, some of which contained hazardous materials. A collision would have created an environmental disaster, blocked a critical shipping channel, and potentially caused casualties among the combined crew of 47 people. The near miss triggered reassessment of the entire situation. Maritime authorities made the decision to essentially freeze Baltic Sea traffic. Ships already in port would remain there. Ships approaching ports would be held offshore. Ships in transit would anchor if possible or proceed to the nearest safe harbor using whatever navigation methods they could trust. The economic impact was immediate. Every hour of delay cost the shipping industry approximately $3.2 million in lost time, missed connections, and supply chain disruptions. Air operations faced different but equally serious challenges. Commercial airlines rerouted flights around the affected airspace. Military operations were suspended except for the electronic warfare missions actively countering the spoofing. But several aircraft were already in flight with insufficient fuel to divert around the large affected zone. They had to complete their approaches using ground-based navigation systems that hadn't been their primary guidance method in years. Pilots who had trained on GPS-based procedures had to revert to older techniques, following radio beacons and radar vectors from air traffic controllers. At 1534 UTC, a cargo flight inbound to Riga encountered the spoofing zone on final approach. Their GPS indicated they were lined up with the runway. Their actual position, verified by air traffic control radar, was offset by 2.4 kilometers. If they had followed GPS guidance, they would have descended into a residential area 3 kilometers from the airport. The air traffic controller recognized the discrepancy and provided radar vectors for a manual approach. The landing was successful, but the incident demonstrated how close the situation had come to catastrophic failure. The NSA analysis team completed their assessment at 1612 UTC. The spoofing operation had been active for nearly 2 hours. During that time, 247 commercial vessels and 34 aircraft had been operating in the affected zone. The false positioning had pushed ships approximately 3 kilometers off their intended routes. In the most congested shipping lanes, this offset had reduced separation between vessels from safe distances of over 2 kilometers down to dangerous proximities of less than 500 meters. If the Swedish patrol aircraft hadn't detected the anomaly when it did, the situation would have deteriorated rapidly. Ships would have continued converging, unaware they were off course. Within another 30 minutes, mathematical modeling suggested at least 3 collisions would have occurred. Aircraft continuing approaches based on GPS would have had a high probability of landing accidents. Search and rescue operations would have been launched in wrong locations based on false distress signal positions. The cascading failures would have overwhelmed regional emergency response capabilities. The spoofing signals were terminated at 1647 UTC. They simply stopped transmitting. GPS signals returned to normal across the Baltic region. Ships and aircraft were able to verify their positions using reliable satellite data. But the restoration of normal GPS service didn't immediately resolve the crisis. 247 ships were scattered across the Baltic in positions that didn't match their intended routes. Air traffic was backed up with diverted flights and delayed approaches. Ports had vessels anchored offshore waiting for clearance to proceed. The maritime traffic system had been thrown into chaos, and restoring normal operations would take hours. Investigation of the transmitter sites revealed they had been abandoned before NATO forces could reach them. The equipment was mobile, truck-mounted systems that could be deployed, operated remotely, and relocated quickly. The sophistication indicated state-level resources. The geographic positioning suggested the operation had been launched from territory outside NATO control, but within signal range of critical sea lanes and airspace. The attack had been a demonstration, a proof of concept showing that GPS infrastructure could be compromised across entire regions. The targeting was deliberate. The Baltic Sea is one of Europe's most critical maritime corridors, handling approximately $250 billion in annual trade. The airspace above it hosts NATO military operations, civilian aviation, and emergency response aircraft. Disrupting navigation in this region created immediate economic, military, and safety consequences. But the demonstration also revealed vulnerabilities in how modern systems respond to GPS denial. Ships and aircraft had become so dependent on satellite positioning that backup navigation skills had atrophied. Many modern officers had never navigated without GPS. Training programs assumed GPS would always be available. Equipment was designed with GPS as the primary sensor. When that assumption failed, decades of navigation expertise became suddenly critical, and in many cases absent. The economic impact was measured in immediate terms and longer strategic concerns. The 2-hour disruption cost the shipping industry approximately $6.4 million in direct delays. Missed port schedules created cascading effects through supply chains. Container ships arriving late missed their connections, stranding cargo and disrupting just-in-time manufacturing. The Baltic states, heavily dependent on maritime trade, faced potential shortages if GPS spoofing became a regular occurrence. Military implications were equally serious. NATO operations in the region relied on GPS for navigation, targeting, and coordination. The spoofing demonstrated that an adversary could deny positioning services across operational areas. forcing forces to operate with degraded capabilities or avoid affected zones entirely. Air operations would be severely limited. Maritime patrols would be compromised. The strategic calculus of Baltic defense had to be re-evaluated under the assumption that GPS could not be trusted. By March 9th, new protocols were being implemented across commercial and military sectors. Ships were required to maintain proficiency in celestial navigation and radar plotting. Airlines developed procedures for operating in GPS-denied environments. Military forces deployed GPS signal authentication systems that could distinguish real satellite signals from spoofed transmissions. The technology existed but hadn't been widely deployed because GPS spoofing at this scale had been theoretical. But the vulnerabilities exposed on March 8th remained fundamental. Modern civilization had built critical infrastructure on the assumption that GPS would be continuously available and accurate. Transportation, communications, financial transactions, power grid synchronization, emergency services, all relied on GPS timing and positioning. The Baltic spoofing demonstrated that this assumption could be violated with relatively modest resources. A determined adversary with a few $100,000 in equipment could disrupt billions of dollars in economic activity and create safety hazards across international transportation networks. On March 8, 2025, GPS signals across the Baltic Sea were systematically falsified for 2 hours. 247 commercial vessels were navigating based on positions that were kilometers away from reality. 34 aircraft were approaching airports using false positioning data. Ships came within 200 meters of collisions they couldn't see coming. Aircraft nearly landed in fields instead of on runways. The margin between normal operations and mass casualties was measured in the vigilance of a single Swedish patrol crew who noticed their position didn't match visual observations. The infrastructure was restored. GPS signals returned to normal. Ships found their true positions and resumed their routes. But the fundamental vulnerability remains. The satellites broadcasting positioning data are in space beyond protection. The receivers trusting those signals can't verify authenticity without specialized equipment. The systems depending on GPS for critical safety functions have no reliable backup when those signals are compromised. March 8th was a demonstration of what's possible. Not a failure, an engineered success. A showing of capability designed to make it clear that modern navigation can be manipulated, that GPS can be weaponized, that the infrastructure societies depend on is more fragile than assumed. The systems are operating normally now. Ships navigate with confidence. Aircraft land on their intended runways. But everyone operating in the Baltic region knows the signals they're trusting could be false again at any moment. The demonstration proved that much. And demonstrations once given can't be forgotten.